What's up? So, same objective. If you know one angle, you should know the pattern to get the other 7 angles, alternating in a zigzag type pattern. 113 is here. All the other obtuse angles are 113, as long as these angles are parallel, which they are, okay? Were you able to do that on your own? Okay. So, then, the other 4 are not congruent, but they make a straight line, which is how many degrees? 180. So 180 take away 113, right? Right? So 180 minus 113? 67 degrees. So let's write that down for all the other 4 angles. So, do you see how that works? If you know one angle, you can figure out all the other angles if you have 2 parallel lines cut by a transversal. Cool? Do these notes. Quick notes, quick assignment. All right, let's look at this. So, we just did this on the warm-up, so you can just do it right now. If angle 2 is 125 degrees, can you label the other 7? So again, this is 125. So then, yeah, angle 3, what else? Angle 6 and angle 7. Cool. And let's write that in at the top. $125 degrees. And the rest, we're going to subtract 180. Yeah, so 180 minus 125 is 55. So these are all acute in another zigzag. So 55 degrees, 55 degrees, 55 degrees, 55 degrees. Write it down. What the heck? Alright. What the what? Let's not say bad words. So, 55, 55, 55, 55. So, again, you got one missing angle. You're able to find all 7 other missing angles using your zigzags. Now, at the bottom, we need to know the relationships of these angles, so let's remember that. Everyone got this part? Okay, number 3. The question is, what angle pair does 1 and 5 make? So since everybody needs to know this, let's pay attention. 1 and 5. Now, remember, we've gone over all the different relationships. So we want to think, are they interior or exterior, or maybe neither? So is 1 in or x? Exterior. Is 5 in or x? Interior. So 5's in between the parallels, right? So 1 is out, 5 is in. So 1 and 5, you can't call them both interior. You can't call them both exterior. And they're not right next to each other, so they're not supplementary or linear pair. So this is that weird one I told you about. So I want everyone to hear this. The weirdest one is this one. All right, looking up here. Looking up here. So this is called corresponding, okay? Corresponding. Now, when I explained this the first time, corresponding is when, bless you, okay, real quick, let me remind you that we should not have headphones in our ears and we should not have phones in our hands. Please give me a minute. Okay, this will be done faster if I don't have to keep saying this. So. Okay. Corresponding is in the same location. So check it out. 1 is in the top left, right? 5 is in the top left, right? Same position. Sorry. Yeah, same position, different intersection. Okay, so 1's in, 1's out, and it's on the same side of the transversal. Okay? Now, we said there's the rule. C is C. Corresponding is, over here off to the right, congruent. And you can tell, because this one's 55, this one's 55. Same thing, right? Same measurement. Do the next one. 6 and 4. So is 6 interior or exterior? In. 4 is interior. They're both between the parallels, right? So they're both interior. Now here's the question. Are they alternate or same side of the transversal? 4 and 6 are on the same side of this transversal. They're both on the right side of the transversal. So we'd call that same side interior. Same side interior. Everyone's getting that down, right? So now S has the S rule. Same side is supplementary. And you can tell because 4 and 6, you got 55, 125. They're not the same. They add up to 180, right? All right. Now, 7 and 2. Is 7 in or out? Exterior, right? 2 is way over here. That's also exterior. So they're both exterior. Are they on the same side or alternate of the transversal? They're on alternate sides of the transversal. So, yes, we call that alternate exterior. Okay? That makes sense? Alternate sides of the transversal, outside the parallels. Let's write that down. Alternate exterior. And you might remember, or maybe not, okay, alternates are congruent. Okay? And you can tell because look, this one's 125, this one's 125. Okay, so alternates are always congruent. So, what angle pair is 7 and 6? Now, looking at 7 and 6, those are what? So, 7 and 6. These are at one intersection across from each other. What do you call them when they're across from each other? This is unit 1. We had a name for them when they're across. Not supplementary, that's next to. Vertical angles, okay? So, does everyone remember that word? Vertical angles? They're across at an intersection. So write down that for number 6. We got vertical angles. And are vertical angles congruent or supplementary? We'll take a look. 6 and 7, they're both. Right? So that's one thing you got to know. Vertical angles across from each other are always congruent. Okay? Now I want to list all the vertical angles on number 7. Tell me some more vertical angle pairs here. 1 and 4, 2 and 3, 5 and 8, 6 and 7. So I'm going to write, those are 4 different vertical angle pairs I'm going to write on number 7. Okay? 1 and 4. 2 and 3. 5 and 8. 6 and 7. Those are the 4 vertical angle pairs that we have on that figure. All right. Now, last one. Linear pair. What's a linear pair? The name tells you linear means line. Line is how many degrees? 180. All right, so 2 angles next to each other that are adjacent that make a straight line, 180. So give me an example. 1 and 2, 3 and 4, 5 and 6, 7 and 8, 1 and 3, 2 and 4, 5 and 7, 6 and 8. There are 8 different linear pairs in this figure. And I know you don't have a lot of room, but we're going to squeeze it in there. So, here we go. One, 2, 3, 4, 5, 6, 7, 8, and 1, 3, 2, 4, 5, 7, and 6, 8. I know that was fast. Write that down. Those are your 8 different linear pairs that make a straight line of 180 degrees. Okay, so I'm going to pass out this assignment. Yeah. So, let me show you what I want on this real quick. One side. Now, half of this is super easy because we just did it twice. So if you see one angle, you should be able to give me all these other angles, right? Okay, good. So real quick, cross out 6 because there is no number 6 on there. There's some typos on here that I need to fix next time if I remember. So there's no 6. But real quick, what you're doing is you're going to give me all these angle numbers. And by the way, this is supposed to be 8 down here. So there's some, this is all messed up. So, here we go. What you're going to do is you're going to tell, so for example, angle 3. What's angle 3? 105 because of the zigzag, right? But I want you to give me a justification that has to do with one of these relationships. So I'll help you with number 3. Ready? So, why is this 105? Because these 2 angles are what when they're across from each other? Vertical angles. So 105 degrees and angle 3 are vertical. You see how I'm giving an example, a reason? Yeah, so it's like answer, reason, answer, reason. There's more than one reason, that's fine, whatever. But just give me a reason, okay? You could have said 3 and 1 are a linear pair. You subtract from 180. Whatever, because you already figured out 1 is 75. So again, tell me the angle, give me a reason. Tell me the angle, give me a reason. Any of these are fair game at the top. Okay, and you know how to get these angles because we did it on the warm-up, we did it on the notes, and you should know how to do this. Cool? Let's get this bread. Woo!